Here we're going to look at example 2, use polynomial identities to multiply from section 3.3. Up top here, I've already written our 4 polynomial identities out so we can reference them quite easily rather than scrolling all around. So for part A, we're asked to multiply 2x squared, or we're given the expression 2x squared plus y cubed, that quantity squared. This one here is going to be right there. All right, so this, if we go back and we're looking at the actual names, we have the difference of squares, and again, there's a lot of things written here, but we have the square of a sum. Okay, so if we wanted to write that, that would be the square of a sum. Now, we would be able to multiply these without the polynomial identities, but the polynomial identities will make our lives a bit easier. So what I need to figure out what a and b are, because I'm going to use a plus b squared is equal to a squared plus 2ab plus b squared. This case, it's pretty simple for me. It's pretty much set up. So I'm just, again, going to rewrite this. That way I can do some highlighting here. And what I'm going to look at is my a value is 2x squared, and my b value is y cubed. It's already in the form that I'm looking for. So now when I plug everything in, I can say that a would be 2x squared plus 2 times that 2x squared times b, which is y cubed, plus that y cubed squared. So it all comes down to substitution. All right, plug in that y cubed, we'll color coordinate everything, and we should be good. All right, so now that I've got those plugged in, I can take that next step and simplify my expression. So 2x squared, that entire quantity squared would be 4x to the fourth. Now we have 2 times 2x squared times y cubed, so that's going to be 4x squared y cubed, and then we have y cubed squared. So when powers to powers means we're going to multiply, so 3 times 2, that would be y to the sixth. And that's how we would multiply this expression. So this would be the original expression multiplied out. In the next example, we have x cubed plus 27y cubed. Here I have the sum of cubes. I have to be careful with this one because a cubed plus b cubed, and then we have a plus b, a squared minus ab plus b squared. What I do have to be careful of is that this is not quite in the form a cubed plus b cubed. The x cubed is good, all right, that is x cubed. However, that 27y cubed, 27 is not going to be my b value. My b value is going to be the cube root of that 27. I'll make that a little bit clearer, which is 3. So we have 3y cubed. I mentioned it in the last video, or 2 videos ago. This is one of the most common mistakes, is using 27 as your b value. So you do need to rewrite that. So now that I have my a and b values, a is going to be x, and b is going to be 3y, I can plug those values in. Let's just color code everything like I always do. So we would have a plus b, which is x plus 3y. Then we're going to have x squared minus x times 3y plus b squared, which is 3y squared. So we do need to simplify parts of this. So we'll have x plus 3y, x squared minus 3xy plus 9y squared. Let me go back and highlight these like I was supposed to. Those 3y's would be our terms. And then that original x cubed plus 27y cubed, my original expression, multiplied out would look like this. Now, again, I've mentioned this before, without the identities for the cube problems, you're going to have a lot of difficulty multiplying these out. You really wouldn't be able to get from that original expression to this without knowing the identities. So be very familiar with the cubed ones. The binomial ones, the difference of squares and the square of a sum are very useful because they will save you time, but they're not absolutely critical to know. The cube ones you must know, you must be familiar with.